um, let's review what we learned in last time about trigonometry, and then we're going to start our last topic. That's just as a review as to what's coming up. This Thursday is Thanksgiving. I guess everybody realizes school is closed, there are no classes. Our next class then is next Tuesday, which is December 1st. We have next week, Tuesday and Thursday classes as usual. And then the following Tuesday, we also have class, and that's our last class. And the final will probably be at the end of not next week, but the following week. We're going to be starting the last chapter, which is chapter 8. That's the last chapter we covered. We actually did chapter 9, and this topic on trigonometry that we're doing is not covered in the book. We just covered it in class. I'm going to review that today. I'm even going to do one more thing beyond what you have to do. You may have noticed that no, actually, it hasn't. I am this afternoon posting a practice quiz and a quiz that are on the topics of conic sections, that's chapter 9, and trigonometry. I would suggest you do the practice quiz first. That is just a homework. What mark you get doesn't count. And then the actual quiz, which is going to be counted like a quiz, like all the other quizzes that we've had this term. So that will have 3 tests on Delta Math and 3 tests on Blackboard, one being the practice midterm, one being the midterm, and one is this quiz on conics and trigonometry. And I probably will be posting at least one example of or pre-practice final as well. And I will let you know how I'm going to be marking that, if I'm going to count it as a test or if I'm just going to count it as a homework. It probably, what I'm thinking of doing is when I post this practice final, if you get a better mark on that than you get on, let's say, one of your other tests, I'll exchange that. I'll use that. Let's say you get a 95 on that and one of your other tests was an 80, I'll exchange the mark. In other words, I will drop your lowest mark. That's what I usually do, is drop the lowest mark. And I would include that if it makes your marks better. If it doesn't, of course, then that becomes the mark that's dropped. So that's what I'm thinking now. I'm not sure. I'm waiting to see what I get from the department as to exactly the time. But at this point, yes, the setup of the practice final will be exactly like the way the final is going to be, the same type of setup, just like the practice midterm was like the actual midterm. And it's going to be basically the same thing as the midterm, that type of setup. It's going to be multiple choice on Blackboard, just the way, except it's going to be, yeah, just different questions, and they're going to be 40 on the final as opposed to just 20, which is on the midterm. And of course, you get longer. You get 2 hours to do it. So that's what we're going to do. Let me just remind you that I'm going to be sending out emails to those people who are missing things. Remember, your homework is going to count for 10% of your final grade. So I will allow you, so far we have 15 homeworks, so probably be 1 or 2 more homeworks on Delta Math. Those are the ones, if you do all except 2 of them, I will give you complete credit. So I will give you a little leeway if you haven't been able to do all the homeworks, but you do. And I want to check if you don't have to get 100 on those homeworks. You have to do them. You have to try every single problem. If you couldn't do them right, you really should have sent me an email and told me you can't do these type of problems. But as again, I'm not looking so much on the homework as to what mark you get. I'm looking that it was done. So that's 10% of your final mark. 20% of your final marks are any tests and quizzes that we've had during the term that I told you it's going to be marked as a test, that the total it's worth 20% of your final grade. Don't forget, if you're missing anything that I have opened up the Delta Math. I have extended the due date, so you should be able to do them. If you didn't do the midterm, or if you want to do something else, just send me an email. If it's reasonable, I will accommodate you as best I can. The midterm is worth 10% of your final grade. And of course, the final, which I don't know what it is yet, is going to be 60% of your grade. Make sure by December 5th that this 40% is complete, because I am going to start, I can't leave it for the last minute to figure out what your grade is. So that 40%, I'm going to start figuring out it by on the 6th of December, so that when the final comes around at the end of that week, all I have to do is figure out what your final exam grade is and average it in. And don't worry, I know how to do it. I take the final grade, multiply by 0.6. It's not a terribly difficult computation, but I have to have all your input. And if you're going to be missing tests, a missing test is worth 0. So I'm going to average in a 0 if I see a test is missing. I will allow you to be missing 2 homeworks, and you could still, if you did all except 2 of the homework, I'll give you the full 10%. But don't forget, it's the quizzes and tests that we've had this term, and there have been 3 on Delta Math, and so far 2 on Blackboard, aside from the midterm. That will be averaged in for that 20%. Don't forget that the practice midterm was considered a test. As I said, it will be posted later today. You will have until December 5th to do this practice quiz, which is going to be a homework. It's practice quiz, and then the actual quiz. Again, as I said, do the practice quiz so you know where your questions might lie. So now let's review what we talked about so far in trigonometry, and let's finish that topic. And I'm going to erase this because I just need the void space. Let's review the trigonometry by doing a problem. And then I'll go a little further on the type of problems we can do. And then I'm going to give you one to try, and I'm going to give, while I take a test. So let's say this is what we learned the other day. This is what we learned on Thursday. We have a right triangle. We call this, let's call this angle theta. Remember, we use Greek letters are very often used as the names of the angles. They can use capital, regular capital letters A, B, and C, or you can use Greek letters. Anytime you see a Greek letter in the topic of trigonometry, the thing that's being referred to has to be an angle. They don't use Greek letters for the sides for some reason. This is just standard operating procedure, as they say. Let's say I gave you, in this triangle, this side being 5, and this side being 9. I gave you a right triangle. I've given you two sides of the triangle. What I'm going to be looking for is, number one, the third side of the triangle. And then we want to know what are the values of the the 6 trigonometric functions that we talked about the other day. We talked about the 3 primary ones, which are the sine, the cosine, and the tangent. And then we also talked about 3 others that we called either secondary or the reciprocal trigonometric functions. And they were the cosecant, the secant, and the cotangent. And I'm just using the abbreviations that we used for them. I put them this way because the cosecant is the reciprocal of the sine. That's why it's called the reciprocal. Remember, these are all fractions. All of these values are either called ratios or fractions. Now, sometimes they change the fraction to a decimal, but basically these things are all fractions, and they get them by dividing one side of the triangle by the other. And these are called the reciprocal functions because each one of these is the reciprocal. They're fractions, so you can flip them upside down. If you flip the sine upside down, you will get the cosecant. If you take the reciprocal of the cosine, you'll get the secant. And if you take the reciprocal of the tangent, you'll get the cotangent. And if you remember, the way I said to remember it is, the cotangent is easy to remember that it goes with a tangent. But the sine starts with an S, so its reciprocal can't start with an S, it has to start with a C, so it's cosecant. The cosine starts with a C, so its reciprocal can start with a C, so its reciprocal is the secant. C with S, S with C, that's how I remember it. I also gave you a mnemonic device for remembering what the sine, the cosine, and tangent are equal to. That was this SOHCAHTOA. And truthfully, anytime you're going to do a test or anything that involves trigonometry, the first thing I would do is write down this word SOHCAHTOA. Remember, picture somebody coming in from the cold and soaking their feet in a basin of hot water to warm up. That's SOHCAHTOA. Okay, so now that we know this information, let's see how we would proceed in a question like this. So first of all, one of the questions that you might encounter on a quiz or on the final is going to be, here are 2 sides of the right triangle, find the third side. And we do that using the Pythagorean theorem that tells me that a squared plus b squared equals c squared. And the c is always the hypotenuse. Now let's label this. There are 3 sides in this right triangle. The side that is opposite the right angle is what we call the hypotenuse. I'm just going to abbreviate it high. Then there are 2 other sides. Now, depending on their relationship to the angle that we're interested in this case, we're interested in this angle. This is my theta. One of these sides is going to be opposite the angle, and one side is going to be adjacent. The opposite side is the one that's across from it. So this is my opposite. Now it's the opposite of theta. If this would be the angle that I had been interested in, then the opposite side would have been this one, because it's across. So we always have to say, what angle are we looking for? That's why we never say find sine. We always say find sine theta. So you know how to set up your triangle with your opposite, your hypotenuse, and of course, this is the third side, is called the adjacent side. That's because it's the side that's right next to the theta. That's not the hypotenuse. The hypotenuse is always the one that's on the slant. Okay, so in this case, they gave us two sides of the right triangle. They gave us the side that was opposite the theta, and they gave us the hypotenuse. And I want to figure out what the third side of the triangle is. And again, as I said, we're using the Pythagorean theorem. So we're going to do a squared. Let's call this a. It doesn't matter whether you call this one a or b. It doesn't matter. You just have to be careful that the c always goes with the hypotenuse. So it's going to be 5 squared plus b squared equals 9 squared. And 5 squared is 25 plus b squared equals 81. And the first thing I have to do is bring this 25 to the other side. And I have to do 81 minus 25, which gives me 56. So b squared equals 56. And that means that b is the square root of 56. Now, usually when we're solving an equation like x squared equals a number, we should get two answers, one being the positive answer and one being the negative. But since this represents the side of a triangle, it can never be negative, so we just use the positive square root of 56. We could actually simplify this, because 56 can be written as the square root of 4 times the square root of 14, which is 2 radical 14 in a simplified form. So that's question number 1. Can you find the third side of a right triangle if you know two of the sides? And we can using the Pythagorean theorem. Okay, now, that might be a question that would be asked on my quiz or on the final. They also could have said, okay, I'm giving you two sides of the right triangle, find the tangent, or any one of these. So let's now go and find the sine, the cosine, and tangent of this. Again, it wouldn't be in the same question because it's just too much material, but these are all things that you might be required to do if you were if you had a question on trigonometry. Okay, so if you remember, we said the sine is opposite over hypotenuse. Now remember, we've labeled, it's a good idea to do this, label your sides, so then it's very easy. The opposite in this case is 5, and the hypotenuse is 9. So in this particular example, the sine of theta is 5 over 9. I can right away tell you what the cosine of theta is, because the cosine of, what the cosecant of theta is, because the cosecant of theta is the reciprocal of the sine. So therefore, to find what cosecant theta is, I just have to flip this fraction, and this gives me 9 over 5. Notice I said these are fractions. if they ask you what's the answer in decimal form, all you have to do, let's say if you wanted to give this answer in decimal form, what you could do is just go to your calculator and do on your calculator 9 divided by 5. And I'm sorry, 5 divided by 9. That's what this says. 5 divided by 9. And you get 0.55. Usually we go to 3 decimal places. This is 0.55555. So it rounded to 3 decimal places would be 0.556. That's if they wanted it in decimal form. Usually we give it as a fraction. Okay, let's go to the next one. Cosine. Cosine is cot, adjacent over hypotenuse. Now remember, the adjacent side is 2 radical 14 over the hypotenuse, which is 9. Again, if you wanted it in decimal form, you would go on your calculators and go 2 times the square root of 14. I'm just going to do this while I talk, say it. 2 square root of 14 divided by 9. And that would give me in decimals 0.831 if I'm going to 3 decimal places. So again, it's just a matter of sticking it into your calculator and working it out, depending on what kind of answer they want. Do they want an exact answer as a fraction, or do they want a rounded off decimal answer? And the question will tell you exactly what is required. Okay, since the cosine was 2 radical 14 over 9, the secant is the reciprocal, so it would be 9 over 2 radical 14. Now, the problem with that is that we don't like to leave a radical in the denominator. We want to rationalize this denominator. Now, this is a single term, so all I have to do is multiply the top and the bottom by radical 14. So that'll give me 9 radical 14. And here the radical 14 times the radical 14 just becomes regular 14. And 2 times 14 is 28. So in radical form, your answer would be 9 radical 14 over 28. Finally, the tangent is TOA. Tangent is opposite over adjacent. So here is my opposite is 5, and my adjacent is 2 radical 14. Again, here I have a radical in the denominator, so I have to multiply radical 14 times radical 14. And again, I would get 5 radical 14 on the top. And on the bottom, just like we did before, we have 2 times 14, that's 28. So in radical form, exact radical form, it would be 5 radical 14 over 28. The cotangent, and I'm going to go to what I had originally, is the reciprocal. I don't want to take the reciprocal of this one because it'll put a radical in the denominator. Take the original one, the 5 over 2 radical 14. When I take the reciprocal of that, that gives me 2 radical 14 over 5, and I don't have to rationalize this because I only have a 5 in the denominator. And now I've gotten 1, 2, 3 of the primary trigonometric functions, and 1, 2, 3 of the secondary or reciprocal functions. And this is basically what we learned how to do we learned how to do this on Thursday. I want to take this a step further. I don't think this is something that you're required to know how to do, but I think it might be interesting to see it. So I'm going to erase this because we don't need this anymore. We figured it out. And I want to go back to that first idea that the sine of theta we found out was 5 over 9. Theta is an angle, and I hope most of you have a calculator with you, because we really are going to be needing our calculators, certainly for what we're doing now. It definitely is helpful, but absolutely necessary for our next chapter. Theta is an angle. Now, in this triangle, we have the three sides of the triangle. Any triangle consists of 6 parts, 3 sides and 3 angles. We actually know what one of the angles is. We know that one angle is 90 degrees. Trigonometry can help us find the remaining angle. Again, I think you should know this because it's important, but if you, it really is rarely asked. I don't really think they ask this anymore on the final. So I just want you to see how to do it. Take any one of the, it has to be one of the primary ones. And you could do this with any one of them. On your calculator, there are buttons, one that says a sine, one that says cosine, and one that says tangent. Now, if you have a calculator that doesn't work this way, you're going to have to send me a picture of your calculator and I'll tell you where to find it. But on my calculator, actually, those buttons are right here, sine, cosine, tangent. As I said, I don't want you using one of these calculators, but any scientific calculator will have buttons for trigonometry. Now, it doesn't have the cosecant, secant, or cotangent buttons. That's why I have to use one of the primary. That's why these are primary, because they're more, the ones that appear actually more frequently. Okay, so above or below these buttons, you may see something that looks like this. Sine with a little -1, cosine with a little -1, and tangent with a little 1, -1. Those are called the inverse. What do they do? I can use these buttons to figure out an angle. I can feed the calculator a number like 5/9 and tell it that it's from the sine, and it'll give me back in response what angle has that sine. I do that by pressing what's called the second button or the inverse button, and then pressing the sine button. Which gives me the inverse sine, and then put in the number that's the sine, which in this case, it's gonna, what usually happens when I press those buttons, second sine, it pops up sine -1 with a parentheses. You then put in, this is after you press these 2 buttons, you get this on your calculator, on your screen. You put in the sine, remember it's 5/9, so you put in 5 divided by 9, and you close your parentheses. So that's what I'm going to do right now, 5 divided by 9, and press enter or equals, and I get, this is the number I got, 33 point, and then it goes 7489886, a bunch of numbers. Usually we go to 1 decimal place. It's 33.74, so that gives me 33.7 degrees. It's telling me how big this angle is. And that's one of the major uses of trigonometry. It allows you to go from the side to figure out what the angle is. Again, second sine, you could have used this number if you wanted to. It's harder to put in, but then you do second tangent, and then you do 5 radical 14 divide by 28, and you would get the exact same answer, 33.7. Doesn't matter which one you use. I usually use the one that's easiest to put into the calculator, which in this case happens to have been the sine. So that's something that you can do. Notice sometimes you might be given something like this. Suppose I told you just something like this. I have an angle, let's say cosine A. I'm not going to theta because it's a different triangle. And I know that cosine A is 0.841. I don't know how I know it, but they told me that. Can I find what angle A is? And the answer is yes. All I have to do again is go to my calculator. Now I'm going to second cosine because this gave me, this was the cosine. So I do second. And then my cosine button. So it goes cosine -1 parentheses. I put in the 0.841, close my parentheses and press equal. Now, there's not something I can do without a calculator. I must have a calculator to do this. I would not be able to do this. And I get something that says 32.75, 75413, etc., etc. If I wanted it to one decimal place, my answer would be 33. If I wanted it to a whole number, my answer would be 33. If I wanted it to the nearest tenth, I'd write 32.8. If I wanted it to two decimal places, I'd do 32.75. But it gives me, once I know the cosine, I can find the angle or any one of these the three primary trigonometric functions. All right, so that's one thing that we could do with trigonometry. Something else that we can do. Let's do this one other topic which is something you do have to know how to do. I'm going to be erasing this now, okay? Suppose I gave you something like this. Suppose I told you that the secant of theta is 7/4. Suppose I give you what the secant is. I'm going to be able to figure out what the other 5 trigonometric functions are. And I'm going to show you how to do this. If you're given one of the trigonometric values, then you can figure out the other the way if you follow this pattern. Okay, so I'm going to erase this so I can work on this problem. Okay, so let's write down the, okay, here's my SOHCAHTOA. Let's just remind ourselves of that. And let's remember the 6 trigonometric functions that we have: sine theta, cosine theta, tangent theta are primary ones, and the cosecant of theta, which is the reciprocal of the sine, the secant of theta, which is the reciprocal of the cosine, and the cotangent of theta, which is the reciprocal of the tangent. Now, what information were we given in this case? We were told that the secant of theta was 7/4. That is the information we were given. It's the only information we were given. which really gives me right away, we know what the cosine of theta is going to be, because the secant and the cosine are reciprocals of each other. So if the secant is 7 over 4, the cosine has to be 4 over 7. That is an obvious one. But how am I going to find the other 4 trigonometric values? It's good just for the reciprocal one because that's just easy to flip. So here's what we're going to do. We're going to, first of all, if they gave you the primary one, that's the one you're going to use. If they didn't give you the primary one, in this case, they gave us the secant, which is one of the secondary ones, right away find the primary one. And then draw yourself a triangle. And again, like we did before, put your angle theta over here. What do we know? Well, in terms of theta, this is my opposite side, this is my hypotenuse, and this is my adjacent, just like before, because I put my angle in the same position. If I were working with this angle, then this would be my opposite, and this would be my adjacent. The hypotenuse always stays opposite the right angle. Saying that the cosine of theta is 4 over 7 is equivalent to saying, remember, cosine is adjacent over hypotenuse, means that I can take the 4 to be the adjacent side and the hypotenuse to be the 7. There certainly is a right triangle where the adjacent side is 4 and the hypotenuse is 7, and that triangle has an angle of theta. So I'm going to call this 4, and I'm going to call this 7. And now I'm in the same position I was before, where I have a right triangle when I know 2 sides. I can always figure out the third side of the triangle with the Pythagorean theorem. And then I can figure out the missing trigonometric functions that I don't have. So using the Pythagorean theorem, a squared plus 4 squared equals 7 squared. So I get a squared plus 16 equals 49. And I'm going to subtract 16 from both sides. That'll give me a squared equals 49 minus 16. I really should be able to do that in my head. 33, which means that a has to be the square root of 33. So this third side of the triangle is the square root of 33. So now I have in my triangle, here's my theta. My opposite side is radical 33. My adjacent side is 4. And my hypotenuse is 7. So let's see what we can do here. The sine of theta then is going to be opposite radical 33 over the hypotenuse 7. Which means the cosecant has to be the reciprocal of that, which is 7 over radical 33. Now the problem is that I have a radical here in the denominator, so I'll multiply the top and the bottom by radical 33. To rationalize the denominator, I get 7 radical 33 over, remember, radical 33 times radical 33 is just plain 33. Okay, the cosine we already know is 4 over 7. So the secant is 7 over 4, which is what we were given. The tangent of theta is opposite, which is square root of 33, over adjacent, which is 4. And the cotangent is its reciprocal, so it's 4 over radical 33. Again, we have to rationalize this denominator by multiplying by radical 33 over radical 33. So this gives me 4 radical 33 over 33. Notice all I gave you as a start was what one of the trigonometric functions are. And now we have figured out all 6 of them. The cosine being the easiest one, but the others using the Pythagorean theorem and the triangle. Okay, I'm going to now give you one of these questions to try on your own. And then we'll, while I take attendance. Okay, so here's my question. I'll leave the SOHCAHTOA on the board for you. Okay. So I'm telling you that cotangent theta is 5/3. And I want you to find cosecant theta. And I'm giving it as a multiple choice. Here are your choices. Okay, so your cotangent is 5/3. I want you to find your cosecant. See if you can do that while I take attendance. Okay, Darlenis, I see that. Okay. Just like we did before, what we're going to do is we're going to draw ourselves a right triangle. And just like I did before, I'm going to put the theta over here, though I could have put it over here if I wanted to. Okay, there I see her here. Saying that the cotangent of theta is 5/3 is equivalent to saying that the tangent of theta is 3/5. I always go to one of the primary trigonometric function if they don't give it to me, because I know those better than the secondary one. And we know that the cotangent is a reciprocal of the tangent. So since the cotangent was 5/3, the tangent has to be 3/5. And we know that the tangent is TOA, opposite over adjacent. So here we're going to label our triangle. This is my opposite side, this is my adjacent side, and this is my hypotenuse. again, if this would have, I would have put the theta over here, this would have been my opposite, and this would have been my adjacent. So saying that the tangent of theta is opposite over adjacent means I can take this side to be the 3 and this side to be the 5. And again, I have two sides of my right triangle. I can find out the hypotenuse by doing 3 squared plus 5 squared equals c squared. The c, the hypotenuse is what we don't have. This is 9 and this is 25, which adds up to 34. So c squared equals 34, which means that c is the square root of 34. Now let's see what the question was. The question was to find the cosecant of theta. So to find the cosecant of theta, what I'm first going to do is find the sine of theta. The sine of theta is going to be opposite, so opposite over hypotenuse, which is going to be 3 over radical 34. So the cosecant of theta is going to be the reciprocal. Notice I always start with the primary ones because those are the ones I really know more about. So that gives me the square root of 34 over 3. How many people got choice C as that answer? The answer is choice C. So that's what you have to know about trigonometry. Okay, Tara Goodwin. I'm changing Tara and putting you. Okay. Any question about how to do this now? I hope some of you actually got this answer. Okay, so that basically takes care of our study of trigonometry. As I said, we're now going to be starting chapter 8. The title to chapter 8 is Exponential and Logarithmic Functions. And if we look at the word exponential, the word that we hear in the word exponential is obviously the word exponent. So what makes something an exponential function or an exponential equation? So if I give you something like this, f of x equals 2 to the x power, that is something that's called an exponential equation. Why? Because the variable, the x, is in the exponent. Until now, we had just regular algebraic equations, something like x squared plus 3x plus 5. We always knew what the exponent was. What we didn't know would be the base. Here, we're going to know what the base is. In this case, the base is 2. But what's going to be our variable, the thing that's going to take other values, is going to be the exponent. Very important that the base is always a positive number. If you see a negative in front of it, it means that you're taking that positive base, doing it to the exponent, and then just putting a minus in front of it. The base itself, you can't have a parentheses with a negative number with an x to it. That is not something that's not allowed. Our base, the number that has the exponent, always has to be positive. So if I ask you something like this, find x of 3, then that means do 2 to the 3 power. Now, you know what 2 to the 3 power means. It means 2 times 2 times 2. which gives us 8. I might even have something like this. Find f of -1. That means we're doing 2 to the -1. Notice you have to remember your rules for exponents, because if you don't know how to work with exponents, you're certainly not going to be able to do exponential equations. If you remember, when you have a negative exponent, it means really that you have a fraction. In this case, the denominator is 1. And when we take the negative exponent, it means take the reciprocal. So since the 2 to the -1 is in the numerator, we're going to put it into the denominator and make the exponent positive. Since there's nothing left in the numerator, that becomes a 1. So this becomes just 1/2. Your answers are always going to be positive numbers because your base is always going to be positive. If you get a negative number here for your x, it just means that you're taking a reciprocal. You're putting something in the denominator. But in order to work with exponential equations, you have to be able to work with the exponents. So review your rules for exponents so when we continue this. Now, there is one topic that I want to cover that is extremely important for you to understand. I know sometimes they cover it in the exam and sometimes they don't. But even if this is not covered in your final exam, it's something that is going to be extremely important to you to know in terms of your real life. And that topic is something called compound interest. We're covering it here because actually the formula for compound interest is an exponential formula. But before I go into the formula, let's talk about what do we mean by compound interest. So let's say, I'm going to give you an example, and then I'm going to show you how to do it with the equation. Compound interest comes about in two situations. Situation one, let's say you're putting money into the bank. You're saving up for college education or whatever. So you're putting money into the bank. Not only are you saving your money, but your money is also growing from the interest that the bank pays you. The other place you encounter compound interest, and this I think affects every single one of us, is when you borrow money. And when I say borrow money, it could be borrowing money to buy a car or a house. Buying a house, borrowing money for a house, it's called a mortgage. Or you're using a credit card. And when you're using a credit card, you're also borrowing money. If you don't pay your bill in full at the end of the month, if you pay, let's say you bought something for $100, but you only paid $20, then you are paying interest on whatever you borrowed. And that interest is what's called compound interest. And you have to understand the consequences of compound interest. So I'm going to first take an easy situation. Suppose you have $10,000, that would be nice. And you're putting this money into the bank. And this is not a true situation. Suppose the bank gives 5% interest a year. They're giving you once a year, they're figuring out they look at how much money you have in your account, and then they give you 5% of that money. That is called interest. Now, how do you work this out? Before we do the formula, first of all, any questions that have to do with percent really means 5 divided by 100. You see how the percent sign looks like a 100? The slash is the 1, and here are your 2 zeros. And the slash is telling you that you're dividing. Now, usually we don't use it as a fraction. We change it to a decimal. And any of the formulas that we work that have to do with percents, we first convert our percent to a decimal. Don't ever work with just the 5. You have to convert it to 0.05. To find out how much 5% of 10,000 is, I can use my calculator and just do 10,000 times 0.05, and that gives me $500. Which means at the end of year 1, if the bank is calculating the interest 1 time a year, they're going to give you $500. You obviously have to leave your money in the bank the whole time, which means at the end of 1 year, you'll have $10,000 plus $500. In other words, you'll have $10,500. So here comes year 2. You left your money, you're not touching it, you're not touching anything, you're getting another 5%. So now you have to take the 10,500, because that's now the amount that you have, and multiply that by 0.05, and that will give me $525. The extra $25 that I'm getting happens to be the interest on the interest. I forgot $500 was on the 10,000. The extra 25 is on the 500. So compound interest means that you're earning money, interest on your interest. Of course, now that means at the end of year 2, you have a total of $11,025. So let's go 1 more year. How much interest are you going to get in the 3rd year? Well, now I have $11,025 in my account, so I'm going to multiply that by 0.05, and I get $551.25. Look at the difference. The first year I only got $500. It's the same percent of interest, but now I'm getting $551.25 simply because I've left my money in the bank and I'm getting interest on the interest. So at the end of year 3, I now have adding this up, $11,576.25. So what's happened here is I've gotten additional money because I'm getting interest on my interest. Now, let's see what the formula looks like and how we could use a formula, because this is rather tedious to do. Okay, I'll change it in a minute, Kalucia. The formula for compound interest looks like this. A, which means the final amount of money, I'm going to see it's going to come out of that, is equal to P times 1 plus R divided by N over NT. Now, you don't have to memorize this formula. This formula will be given to you if they ask a question about it. Let's just take each of these letters. Again, the A stands for the final amount of money. The P is what's called the principal, and it stands for the original amount of money. In this case, for our problem, our original amount of money that we had was $10,000. The R is the rate of interest. it always has to be written as a decimal. It will probably be given to you as a percent, but you have to convert it to a decimal. In this case, it's 0.05. The T is the total number of years that you're leaving the money in, or you're borrowing the money for, whatever. In this case, we talked about 3 years. Our T is 3. Now, what we didn't mention is something called N. What usually happens is the bank or whatever lending institution or whatever place you're either borrowing the money or putting the money in, usually doesn't just figure out the interest once a year. Usually do it several times a year. I was doing it in the case of when we were doing it once a year. In other words, let me just put the words here. Annually will mean that N equals once. It's being done once a year. Quarterly is another common way it's done. You know, the word quarter is a fourth. Quarterly means they're doing it 4 times a year. That's a very common. They might do it at the 4 seasons. Spring, March, summer, June, fall, September, winter, December. Those are the 4 times. So that's relatively common. Quarterly, 4 times a year, or it could be even monthly or daily. Monthly, of course, would mean that they're doing it 12 times a year. And you just have to read the question because it'll tell you compounded quarterly, compounded annually, compounded monthly. In this case, we were compounding this annually, so my N is 1. So here's how I work it on my calculator. I put in the principal, which is 10,000, no commas. Put in the parentheses. I'm typing it exactly the way I see it. 1 plus R. Now the R we know is 0.05 divided by N. So divide by 1 because my N in this case is 1. Close my parentheses, and the rest is going to be in exponent. That's why this is called an exponential equation. So remember, your exponent button is the button that looks like this. And NT is, in this case, 1 times 3, which is just 3. The only thing you have to do before you actually put it into your calculator is to figure out what the N times the T is equal to. Now, I'm going to now stick this into my calculator, and you're going to see that I will come out with this number. 10,000 parentheses 1 plus 0.05 divided by 1, close parentheses, exponent button 3. And my final answer comes out to be $11,576.25. It does it all in one step. Just stick it into the calculator. So this tedious thing can really be figured out relatively easy on your calculator. Now I'm going to give you one to try. Hopefully you have a calculator. Here's the problem I want you to try. You needed $1,000 for something. And it was just, you needed it right away. You decided you're going to use your credit card to borrow that money. Now, your credit card probably charges a lot of interest. It's very common that the interest rate on a credit card could be as much as 18% or more. Let's say it's 18%. And let's say you borrowed this money and you said, okay, I really should pay it back, and I'm going to pay it back, and I'm going to pay it back, but you didn't pay it back. And it turned out that you had it for 4 years. And let's say the bank decided that they are compounding it monthly. Which we know that it means that n is equal to 12. And for some reason, you know this wouldn't happen, but for some reason the bank didn't call you on it, except at the end of 4 years they noticed and they said, you have to pay this bill immediately. Let's figure out how much you would owe. Remember, the original amount of money that you took was $1,000. How much do you owe after 4 years if you're paying an 18% rate of interest and it's being compounded monthly? So again, we're going to use that formula, A equals P. Remember now the P happens to be 1,000. Parentheses, 1 plus R. Now remember, the R is 18%, so we have to move our decimal point 2 places, so it becomes 0.18 divided by n. N is 12 to the nt, so that's 12 times t. We said was 4. We're doing this for 4 years. The only thing you want to do first is figure out what the 12 times the 4, the n times the t is equal to. This is 48. Okay, I hope you're doing this together with me on your calculators. 1,000, parentheses, 1 plus 0.18 divide by 12. Do 0.118 divided by 12, close my parentheses, press my exponent button. Remember what the exponent button looks like. It's that arrow up. Mine is located right here. And then I put in 48. Notice I wouldn't be able to do something to the 48th power without a calculator. And I press enter, and my answer comes out to be $2,043, and I'm going to go to 2 decimal places because this is talking about money, so it's dollars and cents. It's 47.8, so this rounds off to 0.48. Looks what's happened. From the $1,000 I borrowed, I now owe $2,043.48. The effect of compound interest is very great when it's relatively high rate of interest. And it's very important for you to know this, that if you're borrowing money, that you should do it at a place where the interest rate is much lower. Let's say you won't need it for a car, then go and get a car loan. Let's say you need it to buy a house, then you must get a mortgage because the rates on those loans are much lower, and then you don't have to pay as much back. It's not how much you borrow that's so much that's important to know, how much you're going to have to pay back in the end. Okay, so let's just keep in mind that there is a practice test and a actual quiz on Blackboard that is on the conic sections and this trigonometry that we were covering. make sure you do the practice quiz first, so you know what type of questions you can, and then do the regular quiz. The practice quiz is going to be considered like homework. The actual quiz is going to be for the mark. It is due December 5th. I wouldn't leave it until December 5th. It's material that we've already covered, so you could do it immediately. We will continue with chapter 8, which is this chapter, the exponentials. We're going to go into what's called logarithms. We will finish that chapter next week and start doing review. If there's any topics that you would like me to review, please make sure you send me an email and let me know. Can you go over topic finding the equations of lines, or simplifying radicals, or solving quadratic equations? Whatever topic you found that difficulty with, I will have time to do some review with you, and I'd like to do that with you. Don't forget that we're really closing in on the final. We only have 3 classes after today, and we still have this chapter to finish. So let's make sure we get everything done in time, and that you should be able to make sure that by excuse me, by December 5th, you have completed all the homeworks and all the quizzes and everything, because that's when I'm going to figure out what marks you are. I will send emails to people that I see are delinquent in anything, so that they can keep, but you should be able to figure this out on your own, what you have not covered and what you are required to cover, as again, 40% of your mark is from tests, homework, etc., aside from the final exam. Have a happy Thanksgiving and stay healthy, everybody. Be careful. And I will see you next Tuesday, which is December 1st. Any questions? Okay, Kalushia, I'm going to change you to present. Thank you. Okay. You too, Shireen. Have a happy holiday, and just stay safe. Stay safe and healthy so we can finish up this term properly and you can get all the credit you need. Bye-bye.